Okay, guys, this is my second recording, and I am hoping that you have gone through the first recording and hopefully you're all okay with it. So I'm go ahead and posting one more recording on sections 2.2 and 2.6. And again, as I said previously, if you have any issues in accessing these recordings or anything, please let me know. And tomorrow, I think I'll ask the IT folks how to convert them into YouTube videos and post it so that you don't need to download, or sometimes Blackboard Collaborate do take some time. So have some patience and please let me know if you have any issues. So I'll start and go ahead and start with 2.2 and 2.6 sections. Again, I'm just going a little bit detour and after 2.2 I'm going to 2.6. Again, the only reason for that is I personally felt 2.6 is much more apt to start after 2.2 than the next section. So let us start that. I am sharing this. Okay. Now again, we are in Math 540 and we are again doing the basic counting rules. And we already finished one, the product rule. Now we are going to do the second most important one, that is called the summation rule. And once I'm done with this, I'm post an assignment on these three sections. And then I'll go ahead and start permutations and combinations and those kind of stuff. And again, please let me know if you all have seen everything, and then I will not waste your time and I'll go to the little bit different ones. Okay, let us start the summation rule. You already seen the product rule. So again, I will explain this with the help of an example. Assume, suppose there are 10 math majors and 5 chemistry majors in your class, and you want to select 2 people, okay, and you want to take them for a conference, and you want to select one math major and one chemistry major. So you want to have both. You want to take them both, but you want to pick one in math and one in chemistry. How many different ways you can pick these guys? Again, we have no favoritism here. Any math major is okay for us, any chemistry major okay for us, but we want one math and one chemistry. You have seen in the product role, you are picking 2 people. Okay, you are picking 2 people, one math and one chemistry. That means you are doing 2 jobs, one after the other. And how many ways you can pick the first job? How many ways you can pick one math major? There are 10 different choices. So you can pick any of the 10 math majors. And then the number of ways of picking chemistry is completely independent of the math. So there are 5 ways you can pick that. So there are 50 different ways you can pick one math major and one chemistry major. This is simple product rule. So I'm going to tweak this a bit. Now I'm going to change this and to or. Okay, that's all I'm doing. Now you want to pick one chemistry major or one math major. And the other is you have anybody's, you don't care. So, but you either want to pick one math or one chemistry. Now how many ways you can do that? Now once I change this and to or, now the problem becomes from product to the summation rule. So how many different ways you can pick the math people? 10, or that means plus, or 5. There are only 15 different ways you can pick one math major or one chemistry major. This is summation rule. That means either or, that is a summation rule and is a product rule. Now I'm going to give you the definition. If you some job can happen in one ways and a second job completely independent of the first one, like exactly like the product rule can end 2 ways, then if you want to figure out the number of ways you can do one job or the other, or it is not and, then the answer is n1 plus n2 ways. So the easiest way for you to remember is, again, like in product rule, you can generalize to any number of things. So n1 plus n2 plus n3 blah blah blah, it can go forever. It really doesn't matter. So the easiest way for you to recognize is whenever you see and, that is product rule. Whenever you see or, that is summation rule. So that is it. So that is the summation rule. But most of the problems when you're doing counting techniques, you have to use both the rules at the same time. Again, that's what, so I'll explain with the help of an example. let us look into this. You are trying to pick a committee, and the choices you have is you have 8 mathematicians, 4 biologists, and 10 doctors. Those are your choices. Now you want to pick, your committee should have 2 people, and those 2 people should be from different backgrounds. How many different committees you can form? So I hope you all understood the question. So your choices is 8 mathematicians, 4 biologists, and 10 doctors. You want to pick 2 people out of all these guys, but you want to make sure both of them should be of different backgrounds. So one is a mathematician, the other can be a biologist, or biologist and a doctor, or mathematician and a doctor. But both should be of different backgrounds. How many such committees you should have? Okay, let us start working on this. So what are the different choices you can have? You can choose a mathematician and a biologist. I'll call M for math and B for biology. Or you can have mathematician and a doctor. Or you can have a biologist and a doctor. So these are the different ways you can form committees, right? Because you cannot have 2 mathematicians, 2 doctors, or 2 biologists. So mathematicians or biologists, or M or D, or B or D. Okay, I'm just being lazy here, and I'm being a little bit shortening that. Okay, so as I said, if you can find out how many ways you can do this job, and this job, because of the OR from the summation rule, all you have to do is add this, the number of ways you can do this job, or this job, or this job. Just add all of them. Okay, now let us figure out how many ways we can do this job. How many different ways you can pick mathematicians? So there are 8 different choices you have. And biologist, this is M and B. So how many different ways you can pick biologists? So 4. So the number of ways you can form the committee with 1 mathematician and 1 biologist is 8 times 4, that is 32. Or use the same logic. Now you want to form a committee with mathematicians and doctors. How many such committees are there? You can have 8 mathematicians and 10 doctors. So there are 80 different such committees you can form, or biologist and a doctor. So this is and please remember that. So there are 4 biologists and 10 doctors. So your answer is 32 plus 80 plus 40, whatever is the number. So I think that is 120 plus 30, 152. Different committees can form. So this is a combination. This is a typical example where you can have a combination of both product rule and the summation rule. See here, in each piece you are using the product rule, and then combining 2 different pieces you are using the summation rule. So this is a typical example. You are going to see some of like this in assignment 1, which I'm going to post it today. Okay, now let us look at one more example like this. We had seen this in the previous video in chapter section 2.1. I'm asking how many bit strings have a length 2, 3, or 5. So all you have to do is, as we discussed before, B2 is the total number of bit strings of length 2, or B3 total number of bit strings of length 3, or B5 is the total number of bit strings of length 5. So if you can find out how many members are in B2 or B3 or B5, by or indicates you have to add them. Are you okay with this, guys? So if you go back and review the previous video or read the section 2.1, you realize the number of bit strings of length 2 is given by 2 square. That is going to be 4. That is 2 times 2. That is where you are using the product rule. Number of bit strings of length 3 is each and everything you can fill it with 0 or 1. So there are 2 cube bit strings of length 3, or Number of bit strings of length 5. There are two choices to fill each spot, 0 or 1. So total number is 2 power 5. So there are 32 bit strings of length 5. So your final answer is 2 square or plus 2 cube plus 2 power 5. You can leave it like this. It really doesn't matter. So this is a typical example where you are using both product rule and summation rule. So that is 2.2. I know this is very short, and I want to keep this recording short as I explained to you before. Now I want to include one more section, that is 2.6. This is a typical application of the product rule. Again, I'll just review a little bit. Here you are aiming to find out, if a set is given to you, how many different subsets it can have. And I'll just give you a brief definition of a set. What is a set means? It is a collection of things that have something in common. So it can be really, don't assume this is all mathematics or anything. It can be bunch of numbers or bunch of things that you wear, like your shirt, socks, and skirts. The things you wear, if you put all of them in one bracket, then that is going to be a set of things you wear. And these are all bunch of numbers, and these are all bunch of even numbers, 2, 4, 6, 8. So the most important thing for you to think whether something is a set or not, all these things, all the members in the set should have something in common. That means if I give you one number, you should be able to recognize that belongs to that set or not. For example, in things you wear, if I give you a car, if I give you the word car to you, you should be able to figure out whether that car belongs to this set or not. Belongs to this set or not. That is the most important thing. See, car is something you don't wear. So car doesn't belong to the first set. Whereas if I give you a sock, sock is something you wear. So sock belongs to this set. So that is a set. 1, 2, 3, these are all bunch of like natural numbers. So if I give you the word 10, 10 belongs to this set. It is minus 5 doesn't belongs to this. This is all even numbers. Say for example 15 doesn't belong to this set, but whereas 14 belongs to this set. So they should have something in common which should tell you whether something belongs to this set or not. For example, if you look into this 2, 3, 17, one just put bunch of numbers, they doesn't seem to follow any pattern. So if I say for example say 29, I have no idea whether that belongs to this set or not. So these are bunch of numbers, but they don't have anything in common. So this is not a set. Please remember. So that is the definition of a set. Subset means it is again another set. There should be a gap between A and a set. I apologize for that. Is a set contained in another set. For example, 2, 4, 6, 8 is bunch of even numbers, is a subset of 1, 2, 3, 4, blah blah blah, bunch of natural numbers. Okay. So I think you all understood the definition of set and a subset. Okay guys, any and what we are trying to do in this, where the product rule comes into the picture, is I'll give you a set and I'm asking how many different subsets that can have. Okay, so list down all the possible subsets and tell me how many are there. Okay, listing out all the possible subsets is much more difficult problem than telling how many are there. So let us first concentrate how many are there. Let us explain with the help of a simple example. Suppose you went to an ice cream shop and they offer 3 kinds of flavors to you: banana, chocolate, and vanilla. So this is a set consists of 3 different flavors. Again, you can take any combination, right? You can mix 2 different flavors, so that's absolutely fine. How many different combinations you can get? You can just pick one flavor, for example banana or chocolate or vanilla. For example, my children don't want to mix things, so they are like, I want only one flavor. So there are 3 choices here. Suppose you want to mix any 2, so you can mix banana and chocolate, banana and vanilla, chocolate and vanilla. So there are 3 different ice cream combinations with 2. You can mix all the 3. That's what I do all the time. So there is only one choice. If you are diet conscious, you can say, I don't want anything. So that is an empty set. Sometimes people just put a brackets, or sometimes people use this symbol. So this is frankly, this is more mathematics. Uh, so the answer in this case is going to be, there is one choice like this: 3 plus 3 plus 1 plus 1. That is going to be 8. So if a set consists of 3 different things, banana, chocolate, and vanilla, there are 8 possible subsets. Of course, when you have how many different combinations, you might want to remove the empty set, but when it comes to subsets of a set, empty set plays a very important role. So this set consists of 3 things, will have 8 different subsets. Okay. Now want to generalize this. Okay. So I'll give you a set consists of 3 different members. It can be banana, vanilla, chocolate, or ABC, or 1, 2, 3, it doesn't matter. How many different subsets it will have? The first thing is put an empty set, or take all of them together. These are the 2 important things which you never forget. Okay, most of the times people tend to forget to put the empty set. Or take all of them. These 2 are subsets because everything is a subset of itself. Now you take collection of all things only with single members. I can take either just A, B, or C. There are 3 like this. Or I can take A, B, B, C, and A, C. So there are 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, and 4 plus 4 is, there are 8 possible things. So if a set consists of 3 members, it has 8 different subsets. If a set consists of 4, how many are there? If you want to generalize this, you can use product rule. See, your set subset can contain A or might not contain A. So there are 2 ways that can happen. Contain A, might not contain A. Might contain A or not contain A. There are 2 things. Similarly, your set might contain B, might not contain B. That is 2 different ways. Your set consists of C or might not contain C. So that is 2 cubed. So that is going to be 8. So if a set consists of 3 members, it has 2 cubed, 8 different subsets. If your set consists of 4 members, by the product rule, A, B, C, D, your subset might have A or not, might have B or not, might have C or not, might have D or not. So there are total 2 power 4, that is 16 different subsets. So if your set consists of n members, then it has 2 power n different subsets. Because I'm multiplying to n number of times. Okay guys, and please remember, one of them is an empty set. Okay, but it mathematically does play a very important role. So if the total number is n, it has 2 power n different subsets. So that is what 2.6. So I'm going to stop the recording at this point. I will post an assignment on 2.1, 2.2, and 2.6. And once you go through these videos, it shouldn't take too much of your time. Please start working on that assignment and email me, or we can meet either on Tuesday or Thursday if you have any questions. So I will stop sharing this. Thank you. I'll stop the recording.